So I think this is recording. I gotta grab my tablet. I have it sitting over on the side. All right. This is a rational function because I can see that the numerator is a polynomial of degree 3 with a leading coefficient of 1, and the denominator is a polynomial of degree 2 with a leading coefficient of -2. So the first thing I want to do with these rational functions is factor both the numerator and denominator. So if I look to the numerator, I see that every term here has an x. So the first thing I'm going to do is factor out a common x. When I look to the denominator, I see that both of these are even numbers and they both have an x. I like my leading coefficients there to be positive, so I'm going to factor out a -2x. What I would have remaining then would be x minus 3, because the -2 times the -3 is the +6 there. All right, so this is not completely factored. I can factor this x squared minus 3x minus 4 to x minus 4. And x plus 1. All right. Now, when it's completely factored, I'm ready to state the domain. The domain of this function is all real numbers, excluding any values that cause division by 0. So the domain of this function f is all real numbers. It's a set x such that x is a real number. X cannot be 0 because 0 times anything would give me 0. And x cannot be +3. That's how we would write this with set builder notation. If you prefer to use interval notation, from -infinity up to 0, excluding 0, all the way up to 3, excluding 3, and from 3 to infinity. So, look at this picture. You're excluding the number 0, you're excluding the number 3, but everything else is in the domain. Any number that you pick in the shaded region, if you plug it into this function, you'll get a related y value. All right, so we've tackled the domain. Now, for these rational functions, when we exclude something from the domain, it will appear in the graph as either a whole or a vertical asymptote. So I'm going to, I don't want to erase my final answer here of it being factored, but I need to give myself some room. So let's move this up to here, and I'm going to erase my interval notation. All right. So I claim that we can reduce this fraction, that both the numerator and denominator share a common factor of x. All right, so let's change colors. This reduced function is x minus 4 times x plus 1. The -2 is down here times x minus 3. When we have common factors, when that 0 is thrown out of the domain, when it cancels, I know that this is going to appear in the graph as a whole, the x-coordinate of a whole. I know that for every whole, I want an x-coordinate and a y-coordinate. So I'm going to come back in just a second and figure out what the y-coordinate is. I know that the x-coordinate of my whole is 0. See, 0 is not a point on the graph, and the whole is not a point on the graph. It's a hole in the graph. It's definitely not on the graph. All right, now what about this 3? Well, this x minus 3 was still in my denominator, and 3 minus 3 gives me 0. This is going to create what we call a vertical asymptote. Vertical asymptotes Asymptotes, whether they're vertical or horizontal, are always lines. So we need an equation to describe the line. This vertical asymptote is the line y equals 3, x equals 3. All right. So I've got my vertical asymptote. I need to be more descriptive with my hole before I have my final answer. So how am I going to determine this y value? If I come over to this original function and plug in 0, then I know in the numerator I get 0, and in the denominator I get 0. And that is undefined. And that was the whole reason that we threw it out of the domain, is because 0 is not related to any y value. But when we reduced this, we came up with a modified function. It's a new function, and it's a little bit of a lie to say that it's technically equal to this without coming over here and saying that x can't be 0 for this guy. But see, I'm going to ignore this, that x can't be 0 for a minute. And I'm going to come in, and I'm actually going to plug 0 in, not into the original function, but into this reduced function. So what happens if we let x equal 0? In the numerator, we've got 0 minus 4. In the denominator, 0 plus 1. In the denominator here, negative 2 times 0 minus 3. So, and this is going to be my y value, because I've plugged in x equals 0. I'm trying to find what 0 is related to, what y value is it related to. All right, so I've got negative 4 times a positive 1. I've got negative 2 times a negative 3. I have negative 4 divided by positive 6. Both of those are even numbers. I have negative 2/3. So I claim that this hole in the graph has a coordinate of 0 and negative 2/3. So we've answered everything that they wanted. They wanted the hole in the graph. We've given them the location of this hole in the graph. They wanted any vertical asymptotes. Well, there was only one hole, and there was only one vertical asymptote, and it's this line x equals 3. And they wanted the domain, and the domain we said was all real numbers, excluding the 0 and excluding the 3. So when you exclude things from the domain, they come and appear in the graph either as a hole or a vertical asymptote. So hey, we're done with number 1. I hope that helps.